Hi, my name is Alex Breen and I am from the AECC University College in Bournemouth. My background is in medical physics and biomechanics, which has put me in good stead for my roles as a researcher using the quantitative fluoroscopy systems and as a lecturer in biomechanics and research methods. At the AECC's Centre for Biomechanics Research, we have a program of work which focuses on the mechanics of the spine at the levels of the joints themselves, investigating the topics of biomechanics, joint degeneration, neck and low back pain, both separately and with an eye to find out how they interact. The way we investigate this with high accuracy is by using advanced medical imaging techniques such as combining low-dose video fluoroscopy and guided motion and bespoke image tracking software to accurately measure the motion of osseous or prosthetic structures in vivo. Quantitative fluoroscopy has been recognized as the gold standard for measuring intersegmental spine mechanics. This does require the use of X-rays to create our images, which means that we have to be very specific in our research questions and the justification of its use. Now, research collaborations are usually driven by either a common research interest in a topic or a marriage of research interests and the skill sets of the investigators. In the past, my research group has been lucky enough to be the party with the interest or the skill set or both, bringing together clinicians, basic scientists and industry. Such collaborations are often driven by clinical problems that require a combination of skills in appreciating the clinical impact of biomechanical disorders or skills using their technologies to investigate the biomechanics of a clinical condition. One of the most engaging pursuits of the clinical/technological collaboration is the challenge of assessing the multi-segmental dynamics from imaging. We've worked with medical device companies such as Zimmer to assess the functionality of spine implants. We've also collaborated with universities both in the UK and abroad to model the properties of the bone, disc and ligaments and muscular components of the spine to better understand their behaviour. Worked with the European Space Agency to investigate how the effects of microgravity during spaceflight might be countermeasured. With recent advances providing high-quality data such as segmental motion using video fluoroscopy, material properties and geometry from cadaveric studies and 3D MRIs, and muscular activity from electromyography, is now a real possibility to link clinical problems with biomechanical measures and formulate or validate industry solutions. Recently, my research group's interest has been in the building of a normative reference database of spine kinematics for the comparison with the spine mechanics of people with low back pain that's considered mechanical in origin. This has led us to three main outcomes. Firstly, the discovery of a potential new biomarker for chronic non-specific mechanical low back pain. Secondly, the generation of the largest normative database of normative, continuous, multi-segmental spine mechanics. And thirdly, a wealth of secondary information, including the positions of all these bones in all these positions and all these images that can be used to drive machine learning or finite element models or rigid body musculoskeletal models or clinical investigation. This wealth of secondary data has the potential to drive future studies. So we're looking for collaborators who would like to use this database in its current form for their own purposes, or use the database in comparison with basic science, clinical or industry-based questions. Or if people would like to set up their own unit of investigation and perform these studies themselves, we can provide specialist advice or even some equipment such as these motion frames here. While I've demonstrated some of our previous collaborations on here, these studies are by no means finished, and if other people saw something that they would like to take further, please reach out, or if you have your own ideas on how you'd like to use our data or our skill sets, you can contact us. My contact details are over there, or there is a link to a website where you can see more information about us up there. Thanks very much, and I look forward to talking to you guys in the forum.